Hello my dear friends, we are going to be looking at a math scenario program. Three friends, Jane, Joy and Jolly, went for shopping towards the beginning of first term 2025 and bought the following scholastic materials for the candidate class. Jane bought 1 pen, 4 graph books and 4 pencils. Joy bought 3 pens, 2 pencils and 2 graph books, while Jolly bought 6 graph books, 2 pencils and 9 pens. The other friend, called Jessie, also wants to purchase similar requirement for the new term, but she asked for the price of each so that she knows how much she could request from her parents. So the task given to us, ladies and gentlemen, is that we are to use the concept of row reduction to echelon to help this friend of ours, Jessie, determine the price of each requirement if Jane, Joy, and Jolly spent the following respective 7,000, 6,000, and 14,000 respective. These are in Ugandan shillings, but you can convert to any of your currencies that you would wish to use. So right now, let's first go and talk about what is row reduction to echelon. So row reduction to echelon is also what we call Gaussian elimination. So it is also called Gaussian elimination. So what does it do? This is just a simple method that is used to simplify a system of linear equations by transforming its augmented matrix into echelon form or row reduction form. The goal is to create a staircase of zeros below the main diagonal, making the system easier to solve. For example, we are saying if we have a matrix A, B, C, D, E, F, G, H, maybe K. So the major diagonal comprises of elements A, E, and K. So in row reduction form, we are meant to simplify this matrix into zeros below the main diagonal or the major diagonal. So meaning all that we are going to be doing is to convert D, G, H into zeros. And that means if we also create A, E, K to become, to equate them to 1, in all the struggles we shall be making A, E, K to 1, then making A, D, G, H to 0, indicating that once we have some unknowns, because this matrix shall be multiplied into given unknowns, so meaning we shall be able to get the value of that first unknown, then obviously that's what we do back substitution. The next shall be E, and then the last one shall be obviously obtaining a value or the unknown that corresponds to this and that. So in other words, this is what I'm saying. If we have, for example, 1, maybe 3, 2, we said here we must have 0, we have a 1 here, then we have maybe 3, we have a 0, we have a 0, and we have, for example, 4 here, and this is being multiplied by x, y, z, and this matrix is equivalent to, let me say this is maybe 20, 30, 40. Solving this matrix is very simple because you can see we can begin with the last row. So this is called back substitution. So when we get this row by this column, the 0 goes away, the y goes away, and we have the 4z equivalent to 40, meaning that we can get z equivalent to 10. Then we go back and now have this row by that column. So the x will once again go away, and we'll have 1 times y. So we'll have y plus 3 times z, and everything is equal to 30. So meaning we have already obtained our z, and y will be 30 minus 3z. Okay, so but we know that z indicating that we'll have 30 minus 3 times 10, and this gives us 0. So y will equal to 0. Now we go back and do the same so that we get the value of x. So this is going to be, if we get a row by column, this is going to be 1 times x plus 3 times y plus 2 times z. So we'll have another equation like x plus, okay, 3 times y, then plus 2 times z. So we have 2z, and this is going to equal to 20. So meaning we already have y as 0, so this will be plus 0 plus 2 times 10, and this is equal to 20. So also x is equal to 20 minus 20, and also x is equal to 0. So you can see how we are being able to get the values of x, y, z. So this is equal to 0, 0, and 10. And that's all. So this is exactly what we are going to be doing. Once we do row reduction to echelon, then we shall be finding that solving this problem is going to be simple. So with our problem, we are going to solve this step by step so that we be able to know the price of each item, that is the price of a pen, a graph book, and a pencil. And then after that, we shall be able to understand how much Jesse will be able to spend when she wants to buy all the 3 items. So let's look at the variables that are going to be involved. Let P represent the price of 1 pen, and also let G represent the price of a graph book. We proceed. Let C represent the price of a pencil. So once we finish that, now we can translate each friend's purchase into an equation based on how many of each item they bought and how much they spent. So let's look at Jenny's purchase. So Jane purchased 1 pen, so meaning we shall have 1 times P, giving us P. Then she also had to purchase 4 graph books. Remember, each graph book we said the price is going to be G, so this is going to be 4 times G, giving us 4G. And then also 4 pencils. We said each pencil has a cost called C. So if she bought 4 pencils, then the cost will be 4 times C, giving us 4C. And the total she spent is 7,000 Ugandan shillings according to the information given to us. So for that matter, the equation for Jane will be P plus 4G plus 4C, giving us 7,000. So that is done. We go to number 2. We can go to Joy's purchase. So Joy bought 3 pens, so meaning the cost will be 3 times P, giving us 3P. Also 2 pencils, the cost will be 2 times C, giving us 2C. And then 2 graph books, which gives us 2 times G, giving us 2G. And then spent, that is money spent in total, is equal to 6,000 shillings. So meaning the equation governing Joy's purchase will be 3P plus 2g plus 2c is equal to 6,000. And lastly, let's go to Jolly's purchase. So Jolly's purchase, she bought 9 pens. So that is 9 times p, giving us 9p. And then 6 graph books, that is 6 times g, giving us 6g. Then also 2 pencils, and that is 2 times c, giving us 2c. Total money spent is 14,000 shillings. So equation governing Jolly's purchase, okay, is going to be 9p plus 6g plus 2c is equal to 14,000. Now we have 3 equations. The 3 equations are p plus 4g plus 4c is equal to 7,000, and we call that equation 1. Then we have 3p plus 2g plus 2c. This is equal to 6,000, and that is equation 2. Then again we have 6p from Jolly's purchase plus 6g. It is supposed to be 9p plus 6g plus 2c. This is equivalent to 14,000, and that is the third equation. So now this gives us 3 simultaneous equations, and this can be solved by any of these methods. So methods to solve the above, we can use matrix method, we can use elimination method, and we can use row reduction to echelon. So that means if the question had not spelled out the method to use, we would use any of these methods that could be simpler for us, especially like elimination method saves time and is very quick. Also, if you know matrix, you could use it. If you know row reduction, you could use it. But in this specific problem, we have been told to use row reduction to echelon form. So let's use row reduction. So this is row reduction to echelon, or what we also called Gaussian elimination. Obviously, Gauss was a mathematician, and this method was fronted by him. So now our task is to solve this system for P, G, and C, so that it becomes the cost of pens, graph books, and pencils respectively. So we'll use this method to solve the system of these simultaneous equations. So what we do here is to first write the augmented matrix. So the augmented matrix is just a matrix that is representing the constants, okay? In other words, that generally represents these 3 equations. And this is how we do it. So we have to write 1, 4, 4. You see, this represents the constants here. This is going to be 1, 4, 4, 3, 2, 2, 9, 6, 2. Then we create a line, a vertical line, and we put our constants. So this is how it is going to be looking like. So we have 3, 2, 2, we have 9, 6, and this is 2. Then you can put your vertical line and now put the constants on the right hand side, and this is 14, 0, 0. So you can either use those brackets or these ones, whatever is simpler for you. So now our task is to create zeros here, so that now solving the unknowns that are going to be G, C, and P become easier. In other words, we are saying that this equation actually could be just like this: 1, 4, 4, 3, 2, 2, 9, 6, 2. Then we multiply by P, GC, and then this is going to be 7,000, 6,000, and 14,000. So this represents that, because if I multiply this a row by a column, I'll generate the three equations. So we solve that by first writing the augmented matrix. That's when if we use Gaussian elimination or row reduction to echelon form. So we are going to perform row operations. So we say perform row operations. So if we perform row operations, that's when we can create a 0 here, a 0 here. So how do we create a 0 here? We can either say 3 times row 1, because this is row 1, this is row 2, this is row 3. So we can say get row 1, multiply it by 3, you subtract row 2, and then obviously this is going to create a 0 here. Likewise, we can say 2 times, maybe like 9 times row 1, okay, minus row 3, throw everything to row 3. So this is how we are going to see. This is what we are saying. For row 2, remember we maintain row 1. So maintain row 1 as it is. Then remember here we have 7,000. So this is row 1. And now to get row 2, so as we said, let's use row 1 and row 2. We are going to have row 2 minus 3 times row 1, we throw everything to row 2. Likewise, we can also say that row 3 minus 9 times row 1, we throw everything to row 3. So let's go. Now, if I get 3 times row 1, I get a 0 here. Obviously, this is going to be creating a 0. Now let's proceed and do also the others. So if I get, I'm going to be getting row 2, this is 2 minus 3 times 4, that is 3 times row 1, I put my values here. So if I get 2 minus 12, I'll get, what will I get? This is going to be negative 10. Yes, again I say 2 minus 3 times row 1, so 2 minus negative minus 12, I'll also get negative 10. I do the same for this row. So I said row 3 minus 9 times row 1, I got a 0 here. Now let me do the same. I get 6 minus 9 times 4, so 6 minus 36, I'm getting negative 30. Again, I do it for this other one. I also get, this is going to be 2 minus 36, because this is 4 times 9. So 2 minus 36, is that going to be negative 34. Then I do the same for this side. So row 2, that is going to be 6,000 minus 3 times 7,000. So 6,000 minus 21,000, what is that going to be? Negative 15 or 15,000. I do the same here. I get 14,000 minus 9 times 7,000. So this is going to be negative 49,000. So that is the first operation that I have. Now I have a matrix. I've already created a 0 here and a 0 here. So my next move is to create a 0 here. So meaning now the matrix looks like this: 1, 4, 4, 0, negative 10, negative 10, then 0, negative 30, negative 34, and then we have 7,000, negative 15,000, and negative 49,000. So that is how the matrix looks like now. Next, we want to normalize this. Remember, we also said we can create a 1 here, and finally this will also be we will be able to create a 1 here. So to create a 1, we are normalizing, so we say normalize row 2 by dividing by -10, because to make it 1 positive we have to divide by -10 throughout. So the matrix becomes remember, we maintain the first row as it is. So this is 0. So -10 divided by -10, you get 1. And then also this is 1 because it is -10. Then 15,000 negative divided by -10, we get 1,500. And then the last row, we maintain it the way it is. So we had 0, -30, -34, and then -4900. So next we create a 0 here, as we had said. So what do? We can, so we eliminate -30 on the last row, making it 0. So how do we do that? Now that can be done if we got, for example, if we use row 2, we multiply it by 30, then we add row 3. So meaning if we get row 3, we add 30 times row 2, then we throw everything to row 3. So how will that look like? So remember, we maintain the first rows. Now also this is okay. This is 7,000. This is 1,500. This is 0. Remember, if we apply this rule, or this operation should still apply on these two zeros. Meaning, if I get 30 times 0, I mean 0 plus 30 times 0, I should also get 0 here. So it shouldn't change the math here. So what about this next one? We have -30 plus 30 times 1. So that also becomes 0. Now we continue. We have -34 plus 30 times what? Times row 2. So that means 30 times 1 plus -34, and that becomes -4. So we do the same here. We get -49,000. We add 15,000 times 30. So that becomes -4,000. So for now, we are going to be solving the variables. So now the matrix for solving, the final thing is going to look like this. You have 1, 4, 4, you have 0, 1, 1, you have 0, 0, -4. Then you have, remember we had our equations like this. We have PGC. So we have PGC, and this is equivalent to 7,000, 1,500, and -4,000. If we wanted, we could also normalize this. Okay, maybe let's normalize. So normalize the last row by dividing by -4 throughout. I mean by dividing -4 throughout this row. So this becomes, this would mean, if you divide, so this would mean this would be 0, 0, and 1, and then this would be 1,000. This would be 1, and this would be 1,000. So that means meaning solving for unknowns, that is G, P, and C. So the matrix would become 1, 4, 4, 0, 1, 1, 0, 0, and 1. Okay, then we have G. Let's see if that is the order. It is PGC. So this would be PGC, equivalent to 7,000, 1,500, and 1,000. So we begin with C. So that means 1 times C is equal to 1,000, meaning that C is equal to 1,000. We proceed going upwards, so this is going to be a row by column. We did this row by column. 0 times P 0 plus 0 times G plus 1 times C would give us 1,000. Then we get 0 times P plus 1 times G plus 1 times C. So this is going to be 0 plus G, okay, plus C. This is equal to 1,500. So that means G will be 1,500 minus 1,000, which is C, giving us 500 shillings. So that is the graph book cost. Then we go again, this first row times this column. This is going to be 1 plus P plus 4 times G plus 4 times C, equivalent to 7,000. So meaning you have 1 times P plus 4 times G plus 4 times C. This is equal to 7,000. So P plus 4 times G, G we know 500, plus 4 times C, C we know it as 1,000, and this is equal to 7,000. So P will therefore equal to 7,000 minus, this is 2,000 plus 4,000, that is 6,000. And this one also would give us 1,000. So meaning now, therefore, the cost of a pen is equal to 1,000. Graph book is equal to G, that is 500, and what else? Pencil is also equal to 1,000. So meaning if Jesse wanted to buy at least one pen, one graph book, one pencil, then she would say, so for P plus G plus C, this would be 1,000 plus 500 plus 1,000, and she would need 2,500 shillings. So ladies and gentlemen, this problem has been lengthy, but it's worth it, and that's how you can solve this scenario problem. Remember to subscribe, share the link, like, and give us comments in order to see or know how we can improve and serve you better.